Hello everyone, I'm Alan Gregory from Spectrum 3847. We had a request to show how we make our battery cables. So I went ahead and got all of our tools out and everything we need to do that, and we're going to put together an entire battery assembly the way that Spectrum does it. There's a variety of right ways to do it. This is the one that we found and we prefer at the moment. And I'll go through some of the exact details of how we do everything. Some of the tools we use, and I'll make sure to put the links and things in the bottom of this video, in the description of this video, for everybody else to do it this way as well if you want to learn how we do it. Okay, so the first thing we have to do is get our battery cables ready and cut. So we use 4-gauge Tough Flex welding cable that we buy on Amazon. It works well, it's flexible enough. It's not the super noodly stuff, it's also not super stiff. It seems to be a good middle ground for price and everything else and stuff we use. We already had a black cable cut that we had extra from the last time we did batteries, but I do need to cut a new red cable. We cut all of our battery cables to 8.5 inches. The standard, like Kit Parts and Andy Mark batteries, I think are 12. We went all the way down to 6 one year, that was too short. We've settled on 8.5 as being the length that we like for batteries. So we end up just coming over here, getting a ruler and measuring it out to 8.5. We use these Stanley cable cutters to cut our big battery cables. It makes it a really easy process. It just goes and snaps right through it, no effort at all. Having the right tool for the job makes this a lot easier than trying to cut it with any sort of other thin wire cutters that aren't designed for this big of a gauge. Once we have our 2 batteries, we can double check that they are right about the same length. They don't have to be exact, they just need to be close. And from there we need to strip off both ends of the battery so that we can put our connectors on them. So we're going to put a Anderson power pole or SB50 connector, the Tyco Electronics ones that we can get in the Kit Parts voucher work as well. And then also a battery lug that's going to clamp on, and this is what's going to actually bolt to the battery. So we need to have both of those ready. And then we need to strip our wires to the right lengths. We have a specific tool that we use to do this. I'll have the link for this in the description as well. This one works really well. It makes stripping the larger battery cables a really fast job, and we don't lose strands or mess anything up very often. And I might in this video. It happens sometimes where you lose a couple strands when we're stripping them off. But basically you just want to get there and you want to get the length based on the lug you're using. You want the wires to just about hit the back, but not quite, because you don't want any copper showing when you push the lug all the way down. You want it to seat really nicely against the insulation. And so if you get it maybe about a 1/16 of an inch away from where it was going to end, if you butted it all the way up against, mark it. I'll normally try to dig a fingernail into it or so to mark it. And then I will take the tool that we have here and just clamp it over it. And it has a little tiny blade in there that allows us, as we rotate the wire, it's just going to strip, it's just going to cut through that insulation very cleanly. It might spiral sometimes, and that's fine. We just want it to get cut enough to where I can then bend it off and pull all of that insulation off, and I'm just left with that bare wire. We don't want to twist anything here or do anything, because since we are using 4-gauge wire, it is a little bit tricky to get them into the contacts sometimes, so we have to be very careful with how we go about doing this. And of course, doing it on video means I'm probably going to mess it up, but it is possible to do it cleanly without any strands coming undone. Let's see if I can do it. Well, showing it does take a little bit of delicate hands. You're not trying to twist too much. You're just trying to get them all to fit in there and to get pushed down on top of it. And I was able to do it with a couple strands came out. We'll call that good for now. I missed 3 strands. That's not going to hurt anything if there's 3 strands coming off from the battery. And then we'll just take snips and snips those ones off so they're not hurting us anywhere. We're just going to make sure that's pushed down as much as we can, and that we don't have a lot of copper showing from around there. If there's a little bit, it's fine. We're going to go ahead and cover that up with tape at the end. but you want that pushed down pretty far, and you want to be able to see the copper in through that opening right there. You should be able to see it almost touching it. So you want to make sure it's nice and seated and everything is connected there. And then we'll go ahead and crimp this in a little bit, but I'm going to go ahead and strip the other end for the Anderson cable. I'll do the same thing, kind of judging where the back of the cable is going to be and how much we need to strip off to be able to put it back there. Same wire stripping tool again, and we just kind of rotate through fully. Like I said, sometimes it'll spiral a little bit. It's normally not a big deal. It'll still let you kind of pull it off and cut it. There it goes. All right. When we're setting up this cable, we want to make sure that the Anderson is going to clip on, and we're going to be able to bolt in our connection the way we actually want it to be done on the battery. So the cable normally has some amount of like a natural bend to it from how it was coiled when it was like shipped to us. And so we're going to set it up so that when this is connected here in this fashion, the Anderson connector, or the crimp, is going to be the correct way to match the housing. So this is the negative side of the housing, so that means this is going to be on my right side. So I want to make sure that the Anderson is going to clip over the correct direction to match the negative side. So that's going to make it basically go on kind of like this. Ooh, I'm out of frame. It's going to go on like this when we actually go and put it on the wire. So I'm going to go ahead and do that now. Again, we don't want to twist or make these wires any bigger than they need to be, because they are just a little bit tricky to get to fit inside of these Anderson housings. They do take a little bit of work to do it delicately, but when done well, you can see you can get all the strands inside of there, and it will just slip right on down without any work, and it'll go straight onto that 4-gauge cable. So now we have our cable set up the way we want it. So I know that this end is how we're going to bolt it, and I know that this end is going to fit into our the negative side of our Anderson housing properly. So that means I can go ahead and crimp this cable. The crimper that we use when we're making our batteries is one of the hydraulic die crimpers. I think we got this one off Amazon. You can get a similar one from Harbor Freight. There's other versions on eBay. They all do about the same thing. The biggest thing is you just don't want to be using any sort of manual crimper. There are ratcheting crimpers that do work. We used one for a long time before we got this. And as long as it should take a lot of force to really crimp them down, and you make sure there's no way they're able to get pulled out or anything like that. This definitely does the best job from what we found. It's about 50 bucks or so. It's a pretty good investment if you're going to be making a lot of batteries. The way they work is you have an off and an on. When it's on and you pump this, the die closes. When you rotate it to off, it'll release, so you can uncrimp it. This might be kind of tricky to get in frame, so I'm going to have to be like pushing into the table and things to make sure that I can get this fully crimped the way we want it. You do want to make sure that, especially for the Anderson part, you're crimping in the direction of the contact, so that if it widens out at all, it can still slide into the Anderson housing. If you crimp it kind of 90 degrees, sometimes it'll get too big and won't actually fit in the housing. That's not something we want. Let's see how well I can do this. It does take a little bit of time to keep pumping it to get it to close all the way. Once we got it, we can start really giving it quite a bit more force. Do we not have the right dies in here? I might need to switch dies. Did not seem correct. One second. So someone had moved something since the last time I did this. This is the case it comes in. These are the dies you're able to use. I thought I had the right ones in here, but maybe we didn't. How well is that crimped? That did crimp pretty well. We'll go ahead and say that's good. Normally it takes a little bit more force to do it, but maybe it's doing okay with that. Alright, if it ends up being a different die, I will find out shortly, and I may switch it after we do a couple cables if it doesn't look like the tug test is going to work. Okay, so we'll go ahead and do the other side. I normally like crimping up towards the top first and then doing the bottom. Not really sure where I picked that up from. That could have been the other way is the better way. So don't quote me on that one. But as long as you get, we normally do it twice on the bigger lugs. And that seems to work well. And we definitely want to make sure it crimps all the way to where the contacts are touching. And that you can't really pump it anymore. So that's all the way the contacts are touching. We cannot do that anymore. So that'll open up again. We have pretty nice crimp there. And we'll do it again towards the back of the contact. It's definitely a little awkward to try to do it on camera. We'll see how well this works. Everything lined up. Yeah, sometimes if you can't quite grab it, you have to put it on a table and push onto it. Like, it does take quite a bit of force to really get these things cinched down. But you don't want these getting loose at all. All the power running through your robot is running through these connections. These are one of the most important connections on your entire robot. You want these things very, very tight and crimped well. Okay, that seems to have done its job pretty well. I don't think I'm moving that at all, so I'm going to call that good. You can see it did crimp it to where you got a nice little crimp all the way through the connector. It gave it that kind of hexagon shape that we want, and it's going to seal in and not be able to come undone, basically no matter what we do. Okay, we're going to do the same thing we just did for the red cable. I'm not going to describe it as much since we just did it. But I'm going to go through that same process again, figuring out about how long we need it, marking it, getting it stripped. Hopefully. There we go. And this sometimes can be trickier than others to want to fit into these terminals. course, it messes up when we try to do it on video. For these, since they are 4-gauge, you can get 4-gauge lugs for them. That's what we normally use. I was doing them with the kit of parts lugs for this video, which we had done for years, and it does work, like we just did on the other one, but sometimes they don't work as well, and you end up getting some kind of messed up wires. And try to straighten them back out and see if we can get it to do what we want. Alright, that one had a few more strays. We'd still call this okay. I wouldn't want too much more than this. This is probably about 10 strands of the 4-gauge gone. Probably wouldn't want any more of that if we were doing it and trying to keep the wire. But for video, this is okay. 3 strands, 4 strands, I'm normally not worried about it. 10, I would probably have the students redo this. But to keep it nice and keep the video moving, we're going to go ahead and say that's good enough for now. Clip down as far as I can get that. Alright, so we got to do the same thing where we set it up with the battery so we know which way it's going. So this one's going this way. I'm going to kind of turn the battery cable so that they both want to be going in towards each other. And then we make sure the Anderson's going to be going that direction. Alright. Same thing as before, figure out how long it needs to be for the wire stripping. Off that bit of wire. And again, with the Andersons, you can do it with no strands being left out at all. It does fully seat nicely into our Anderson crimp. Alright, so we have this set up the way we want this cable. Should be the inverse of the way we have this cable. And we'll go ahead and do the crimping again. Make sure that's turned on. Get this set up here. Alright, so that should be good. That looks alright. Do the same thing twice over on the other side. Alright, that seems pretty good. Back it off, and one more time. That should be good. Okay. So now we have our crimps done. So now we have to, all that's left is to bolt this up to our battery. I'm going to go ahead and feed these. Oh wait, did I end up doing this one wrong? This might have rotated a little bit. It'll be alright. The cables are flexible enough to where even if you don't set this up exactly the way you wanted it, it'll still work for what we need. But we're going to go ahead and put this part that covers the little tang that's on the inside of here, make sure it's into the one that says positive, and we're going to feed that through, and it's going to get pushed through, and we make sure it actually clicks over the top like that, and it's ready to go. We're going to do the same thing with the black one. We have the little clip, we have the tongue. We're going to feed that one through, make sure it clicks and can't come out. Neither of those can come out, which is what we want. We want to make sure there's no copper showing at the bottom of this. It's all just wire insulation, so the housing's doing its job and covering up any of the contacts there. And now we have our connections here that we're going to bolt. So we're going to bolt in our connections here using the specific hardware that we use. So we use 10, I think these are 1032s, I believe is what we're up to now. So we had been using 1024s, we had been standardizing for a long time. I think we switched these to 1032s now, which is what they should be, is what we use on our robots now. So this is a 1/2 inch 1032 socket head cap screw. 1/2 inch works, 5/8 might be better, but right now we have 1/2 inch in our bag, so we're gonna keep using them. And then we have flanged lock nuts that we use. They just have a little bit bigger of a flange on the back side of the nut. I don't know if it matters that much. You can probably just use regular 1032 nuts. We have these specifically for the batteries. They seem to work. We also make sure we keep the bag there. No one takes them to use them on the robot or anything like that. And then the most important part of this process are the lock washers that we use. So these are Nordlock number 10 lock washers that we can get on McMaster. We use these based on the recommendation of Zebracorn's FRC 900 and their battery guide, which I'll also link in the description of this video. And these are by far the best way to ensure that your batteries don't loosen. So if you use 2 of these on each bolt, the way I'm going to do it right now, your batteries will not loosen over time, or just not very much. Way better than using any sort of serrated lock washer, external, any of the tooth ones. Especially don't use split lock washers. Don't use split lock washers on almost anything. But these do a really good job. This combined with the nylon lock nut really hold a really good fit, and that's what we're trying to avoid, is any sort of vibration, anything where we can lose any of that contact between the lug and the battery terminal is what we're trying to avoid when we're setting these up. So here we go. So we're going to take our bolt, we're going to put a lock washer here. We're then going to take the terminal and we're going to bolt right through it with another one of our Nordlock lock washers. Sorry, this is kind of hard to get all set up and get it to where you can see it. Let's see, there we go. So another one of the Nordlocks. And then we're gonna put our lock nut on it. And like I said, having a little bit longer lock nut is definitely, or a little bit longer bolt, going up to 5/8 is better. But the 1/2 will work for this demonstration. Even go into 3/4 and you'll have a little bit of the bolt sticking out. That works just as well. Alright, so I got that one set up. I'm going to go ahead and set up the second one before we tighten these down. We stopped using heat shrink and we use a silicone electrical tape now on our batteries, just so we can inspect them easier, so we can take the tape off, tighten them before events, and we don't have to cut our heat shrink and like redo the batteries entirely and like reapply heat shrink. Other teams swear by heat shrink and use it all the time. We used heat shrink for a long time. There's nothing wrong with it. It works fine if that's how you want to do it. we just stopped so that we could be able to inspect them and maintain them a little bit easier by just having to replace the tape and not having to completely take apart the lugs every time we needed to cut through the heat shrink. So we'll go ahead and show you what that process looks like as well. We normally always bolt from the outside, wrench on the inside, just easier to be able to have the Allen wrench on the outside. But this is kind of the setup that all of our batteries end up looking like. We have our Allen wrench and wrench. Oh, I got the open end socket ratcheting, which I don't love, but we can probably make it work. Let's try to ratchet. There we go. So we just want to make sure these are very, very tight, as we don't want any movement with the inside the battery. Let's see. There we go. All right, then we'll do the same thing over on this side. Make sure this is very tight again. Ratcheting wrench is causing problems. Let's see. There we go. All right. Very, very, very tight. Both those connections are very tight. There's no wiggle. There's no wiggle. If I wiggle this, it only bends at the battery. It doesn't bend at the lugs at all. Alright, battery died before I could tape the battery leads, so I'll go ahead and do that part now. So this is the tape we use. It's silicone electrical tape. We buy it on AliExpress, but you can get it other places. Seems to work well enough for what we want it to do. We haven't had any issues with it. We basically just make sure we get a good wrap kind of coming around it. And then we find the silicone stuff really can work its way around the bolt and the nut on here a little bit better than some of the vinyl stuff. We do have to reapply it probably once or twice a season. That's okay. That's kind of when we're doing the maintenance on it anyway. And we're making sure that they stay bolted together. This stuff is really stretchy, so we want to make sure we're kind of stretching it and it seals to itself. So kind of wrap it around. This is messier than it normally is, but it's alright. And then I'm going to cut it. And the last part we'll just grab and fully wrap around. Alright, so that's kind of our goal, is right there to where there's no metal showing anywhere. That was a pretty decent one. There's no metal showing, it's all covered by tape. It's not the prettiest. Heat shrink is definitely a prettier fit, but we find this to be pretty functional. And we'll do the other side as well. Make sure it's stretched out, adhering to itself. Sorry for the wrapper noise. And we cover up all of the wires. Go ahead and cut that and we'll reapply. I'll make sure it all gets applied. Alright. And so then this comes around. We make sure that's all stuck together the way it wants to be. It'll self-seal to itself. This is probably another okay one. We probably could have gone around another time on the bottom. I probably would. Like you can kind of see stuff slipping down at the bottom where it didn't quite get the tape low enough. That's normally not an issue, but you do want it to be as sealed as you can get it. You don't want to be able to touch these contacts at all. You don't want a wrench or something being able to touch the contacts. That's pretty much what a final battery for Spectrum looks like. Before we go, this battery is actually from FRC 7498. I think this is a battery they used at IRI in 2019, and then Philso got them to us, and these are going to go to a young FRC team here shortly before kickoff, so that they have a few more batteries. But that's what these are going to do, and we're going to make a few more batteries for them. But yeah, so that's the process. Those are the tools we use. Those are all supplies we have. We keep them all in like a specific bin that's just for doing batteries. We don't really use that crimper or wire stripper or anything else for any other parts of the robots. It's just for battery cables and for the battery runs to the main power distribution board or power distribution hub now in 2022. All right, thank you everybody.